Hey there, y'all. It's Miss Campbell. We're going to go through here and we are going to be going through our notes for today. So we've got a new packet, and what we're going to be learning about is angles. So the first thing that we're going to be doing is defining angles and then learning how to name them. So an angle is formed by two rays with the same endpoint. And then the rays are the sides of the angle, and the endpoint of both of your rays is the vertex of the angle. So if you look in our picture over here on the end, you have ray AB and you have ray AC, and they're coming together at the single point A. So A would be the vertex, and that angle there, you could call it angle BAC, or you could call it angle CAB. You could also call it, since it's the only angle right here, you could call this angle A. You can call it by the vertex if it's the only angle that you're talking about. And then the last way you could name this angle could be angle 1, because there's a 1 inside the corner there that's made by that vertex. So naming it, you can name it by the vertex. Again, that's only if it's the only angle there. Or if it's got like other angles around it, you have to name it with the 3 letters. And if you notice, in the middle is always that vertex. So again, angle BAC or angle CAB. And this little symbol that's right in front that kind of looks like a less than, but a little bit different, that's, you say that angle. Okay, so you can call this angle A, angle BAC, or angle CAB, or angle 1. So that symbol means angle. Okay, so angles can only be named by the middle letter. Okay, middle letter, when they are the only angle at that vertex. So that's what I was saying here. We could call this angle A because it's the only angle right there. When angles are named by a point on each ray in the vertex must be in the middle. So that's if you're going to use the 3 letters, your vertex is always going to be in the middle of the name. So next thing here, naming angles. What are 2 other names for angle 1? So angle 1 is this angle right here. Okay, so what are 2 other names for angle 1? Well, it could be angle JMK, or angle, and then you could go the other way, KMJ. Okay, notice how the vertex M is in the middle of both names. Now I could not call it angle M because, as you can see, I have 2 angles coming off of that same vertex there. So if I just named it angle M, I wouldn't know if I was talking about this angle 1 or this angle 2 over here. So types of angles. Y'all, this should be a review for you guys. Acute angle, the measure of your angle is between 0 and 90. Okay, a right angle, your angle is exactly equal to 90. Obtuse angle, your angle is greater than 90 but less than 180, so it is between 90 and 180. And then a straight angle is when your angle is exactly equal to 180. So measuring angles with a protractor. If one ray of the angle is horizontal, you start measuring from 0 and follow the numbers to where the second ray indicates. In the case of the angle on the left, the measure of angle AOB, so we're talking about this protractor on the left-hand side here, we can see that ray OB is horizontal. So we would start at 0 and we go up, 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 and we can see that it's between 130 and 120. So the measure of angle AOB would be 125. Okay, it would be 125. And how you read that, it's read as the measure, that's what that little M means, the measure of angle AOB is 125 in degrees. because angles are measured in degrees. So just be careful. If you're starting down here, we know that ray OB is at 0, so I need to use the inside numbers. Okay, so 0, and I'm measuring up, 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 because the angle is getting bigger, is 125. In this case, if you're starting over here at ray OB, you would not want to start with the 180 and go there. That would not be the right one. On this one, we have to use the inside numbers. Okay, if neither ray is horizontal, as is the case over here on the right, then the measure of your angle is always equal to the absolute value of the difference of the real numbers that each ray passes through. So you got to look and see where your endpoints are. So basically point C, it looks like it's at about 45 because it's between 40 and 50. And then notice I use the outside numbers, right? So when I go over here to the other one, I also have to use the outside, okay? So basically, if you start with outside, you stay with outside. If you start with inside, you stay with inside. So now over here, I can see that it's about maybe at about 1, because here's 145, right? So maybe it's about like 148 or something like that. 148. All right, and then how do we find the measure of it? Well, you take the difference between the two. Now it says the absolute value, but make your life easy. Just go ahead and subtract big one minus small one. So 148 minus 45, because that was the other one here. So 8 minus 5 is 3, 4 minus 4 is 0, 1 minus nothing is 1. So we could say it's about 103 degrees. Okay. And again, always make sure that you use the numbers from the same side. So it's both inside or both outside. Don't mix them up. So now let's go ahead, let's measure and classify this angle right here. So it says, what are the measures of angle LKN, JKL, and JKN? And then we have to classify each one as acute, right, or obtuse. So angle LKN, okay, LKN. So I start right here. Here's L, K is in the middle, and N is right over there. So I'm looking at this large angle, right? Again, I know that I'm going to start from my horizontal ray, so that's 0. I'm just going to read up here. Where does it end about? About 145. So it's 145 degrees, so that means it is obtuse because it's greater than 90, but less than 180. Okay, the next one that they want us to measure, and notice you can erase, just be like with using your pencil too. Make light marks and it's easy to erase it. Okay, our next one is angle JKL. So we start at J, here's K, and there's L. So they want this wedge right there. So I'm going to see here, it looks like L is between 30 and 40, so I'm going to call it 35. Okay, this one here, J is right at 90. So you would just do, so we want angle JKL. Okay, you would do 90 minus 35. So 90 minus 30 is 60. Take away 5 more, so it's 55, which would make it acute. So it's 55 degrees, and that would make it acute. Yeah. All right, next one, angle JKN. Okay, JKN. So again, you can just erase any marks here, and I'm sorry if I leave behind little tiny bits. My eraser is not the biggest right now, but that's okay. All right. Okay, JKN. So there's J, and we're going to K, and we're going to N. Okay, this one's very easy. So we start at 0 and we go up. Where's J? It's at 90. So it is 90, so that makes it a right angle. Okay, moving right along. So our next topic that we're going to discuss for today is the angle addition postulate. So this is just like the segment addition, except we're dealing with angles. So we can see here, they're saying that if point B, so point B right here, is on the interior of angle AOC. So basically you have this big angle AOC, okay, And you can see that inside it's cut up into two smaller angles, right? So they're saying if you take one piece of the angle plus the other piece of the angle, it adds up to this big angle that's on the outside. So just like with segment addition, part plus the part equals the whole thing. So this is one part, this is your other part, and the outside is the whole thing. Okay, so part plus part equals whole. So the two smaller angles added together are equal to the larger angle. So we'll try that out with an example here. It says the measure of angle EFG. Okay, so EFG, right away, I see that is the outside angle. So that's 86. So I'm just going to label 86 outside there. And it says the measure of angle WFG is 62. So WFG is this one over here. It's 62. And they want to know what is the measure of angle EFW. So right there. So basically we have 62 plus, we don't know, so I'm going to use x, equals 86. And then you would just subtract. Now again, I'm doing this the formal algebraic way. You know in your head you probably just need to do 86 minus 62, and there you go. So 6 minus 2 is 4, 8 minus 6 is 2, so it is 24. Okay, but if I'm asking you to show your work and stuff, show me that subtraction. Okay, now we'll go over here. We got an algebraic example. So find x if the measure of angle HJK. So HJK, that's this big one right here. Not the whole thing, but the big obtuse one here. Or at least we think it's obtuse because it looks like it on the picture, but we have to actually figure that out. We have 38x plus 6. Okay, and then they tell us our next part is angle IJH. So IJH is 22. So the small piece is 22. And then they tell us here that the measure of angle IJK is 44x plus 4. Okay, so now, like I said, you cannot make any judgment about what size any of these angles are, except for the 22, because you don't know what x is equal to. And once you know what x is equal to, then you could plug in and find out what they are. So do not go and make the assumption that this IJK is a straight angle, because we don't actually know. So we have to go with what the math tells us. What we do know is that this larger piece plus this smaller piece equal up to the whole total thing here. So 38x plus 6 plus the 22 is equal to this 44x plus 4. So now it's just algebra from here. So part plus part equals the whole thing. So 38x plus, and then 22 plus 6 is 28, equals 44x plus 4. So I'm going to go ahead and subtract 4 over here, and then I'm going to move the 38x over there. Okay, so 44 take away 38 gives us 6. So, and 28 minus 4 is 24. So 24 equals 6x divided by 6. So x is 4. Okay, and that's all they asked for us to do at this point. If they asked us to go and find the measure of those angles, well then we would just substitute in for x, and then we would get our answer. Okay, so now we've got another one here, and we're going to go on to the assignment in just a minute. So now this one here, it says find x so the angle DEF is obtuse. Okay, DEF is obtuse. So we know the two parts, right? So if we add the two parts together, we know that we get the whole angle, right? But the question wants us to find it so that the big angle is obtuse. So what does obtuse mean? It means that it needs to be greater than 90. Okay, so angle DEF, let me write that properly. The measure of angle DEF needs to be greater than 90, but less than 180. So how are we going to get the measure of angle DEF? Well, it's the 11x minus 12, so DEC, plus this 2x plus 10, CEF. So we're going to write our inequality. So 90, and then we have 11x minus 12 plus, and then we have this 2x plus 10. And when we add the two parts together, it has to be between 90 and 180. So now we just go and do our algebra. So 90 is less than, and we have an 11x and a 2x, and we're adding. So that's 13x. And then we have a minus 12 and a plus 10. So that's going to end up as minus 2. Okay, now some people may have done these compound inequalities, others might not. So just follow through here. So it's just like solving a regular equation, or inequality I should say. First thing I'm going to do is add 2. But instead of only doing it on one other side, well, now I have the 180 over here and I have the 90 over there. So I'm going to add 2 here, and I'm also going to add 2 to the 90. So now 92, and then those go away. So we have 13x, and then 182. And then your last step is just to divide by 13. So you just divide everything. So now we do 92 divided by 13, and we get 7.07, some wild number. It doesn't truly matter what it is at this point. So I'm just going to leave it as 92 over 13. Okay, and then we get 182 over 13. You know, that's going to be just as wild. Oh, actually, 182 divided by 13 is 14. So x has to be between 92/13 and 14 in order for this to be an obtuse angle, meaning that it is greater than 90 but less than 180. So again, that's one of those pre-AP problems. Okay, and then the last thing is just kind of a note for diagrams here. It says congruent angles. They are angles that have equal measures. And like on segments, we use little tick marks. On angles, we use little arcs. So these little, they're small curved lines right there to show that those angles are congruent. So in this picture, it is showing me the angle AOB is congruent to angle COD. Okay, so their measures are equal, which means that they are congruent. And we're going to get into exactly what that means a little bit later on. All right, so assignment here. For today, what you guys are going to need to do is to complete the assignment. Just kind of go through here and use all the examples that we've done. Okay. On these ones here, 17 through 20, you can make the assumption that line FI and line JG, you can make the assumption that those are straight lines for you, okay? They are not bent at any strange angles, so yes, those are straight lines. All the lines in the diagram are straight lines. And then on these ones, just go through and solve for x, and if they ask you to substitute in, actually they don't, so I think it should be pretty good. And if you have any questions on it, just let me know tomorrow and I'll help you out. Just on here, I guess on like 7, 8, and 9, you see they're asking for the vertex. So on number 7, they want angle 4, so find the 4. So what's the vertex of angle 4? It would be T. Okay. On here, angle 5, they want you to name angle 5. So here's angle 5, so it would be WTS or STW. Those would be two equivalent names for that. So angle WTS or angle STW. And you only need to put down one. All right, so like I said, if you have any questions, just let me know, and we'll go over this tomorrow. I don't think you should have too much trouble, but just hold on to your questions for me, and I'll see you guys later. Have a great day.